students, today in this module we will be discussing about thermal treatment of waste, incineration. Now, increasing population and urbanization has resulted in the generation of huge amount of solid waste. Now, this solid waste is just dumped or disposed of into an open land. This creates a lot of chaos and environmental and health hazards. Now, to avoid these environmental and health hazards, you should have a proper waste management practice or a plan. Now, the waste management plan starts with waste generation at the source, then followed by waste collection, then comes your transfer and transport to an intermediate station called as your transfer station. Then within the transfer station, you discuss or you conduct the waste processing, then comes your waste treatment. And after the residue that is left out after waste processing or waste treatment, they are just disposed of into a controlled landfill or controlled area, which is generally called as a landfill. Now, the waste that is generated in our previous modules, we have studied or discussed about waste generation, waste collection, how they are brought to an intermediate station called as a transfer station. Then we also discussed about the different waste processing options that are available, like your size reduction, volume reduction and so on. Now, in this particular module, we will be focusing on waste treatment, especially the thermal treatment of waste. Now, here you apply very high temperature where the waste is thermally destructed into compounds like carbon dioxide, carbon monoxide, oxides of sulfur, oxides of nitrogen and so on. So, with this introduction, we will discuss about the thermal treatment of waste, that is incineration. Now, the learning objectives of this module would be to understand the concept and process of incineration, to study the various incineration technologies that are available, then we will realize or understand the different advantages and disadvantages of incineration and the different types of incineration systems which are available. Then we will discuss about the specific application of incineration, where these incineration or incinerators are used, which particular wastes are being treated or thermally destructed. Then we will discuss about the energy generation potential of waste. Now, as I told you, incineration is nothing but a combustion process where the waste is generally burnt in the presence of oxygen at a very high temperature of around 900 to 1100 degrees Celsius. Now, this is an exothermic process where the waste is converted into simpler compounds like carbon monoxide, carbon dioxide, oxides of sulfur, nitrogen, depending upon the nature of waste. Now, why this 900 or 1100 degrees Celsius is chosen is that this temperature will ensure a good combustion, complete elimination of odor, and it will also protect the walls of the incinerator. Now, incinerators are considered as the best alternative route for treatment and disposal of solid waste, because a huge amount of reduction in volume and mass of waste occurs. In volume, almost 90% of the waste volume is reduced, and in mass it is reduced by 75%. And what are the end products? One, it is the inert residue ash. Second is the flue gas, and within the flue gas you have a mixture of water vapor, nitrogen, carbon dioxide, oxygen and so on. In addition to this, you also have the production of certain other compounds like your hydrogen chloride, that is HCl, hydrogen fluoride, then volatile organic carbon, dioxins, furans, PCBs and so on. Again, this depends upon the nature of material or the waste that you are combusting within the incinerator. The residue or the ash that remains at the end of incineration process is generally of inorganic nature, and they are generally inert, they do not show any reactivity, and it is very easy since a maximum amount of volume is reduced, it is easy for you to carry them and then dispose them off. Now, there is a problem with incineration process. During this process, the flue gas that is released out contains a lot of particulate matter. Now, this particulate matter, when it is discharged out into the atmosphere, it becomes an air pollutant. So, you have to fix certain air pollution control devices to this incinerators to avoid the air pollution problem. Specifically, you can, if you talk about the air pollution control devices, the electrostatic precipitators and the baghouse filters can be a very good option for controlling the particulate matter or removing the particulate matter from the flue gas before it is being discharged or emitted into the atmosphere. But this adding or fitting air pollution control device, obviously it adds to the cost of the incinerators. Now, as I told you earlier, incineration reduces the volume of waste by 95 to 96% and mass by 80 to 85%. This again depends upon the composition and the degree of recovery of materials which are present in the waste. Now, since the incineration process involves a very high temperature, it is suitable for waste that contains pathogens and other harmful organisms because they are generally killed at this particular temperature. Now, this is the reason why incineration process is more suitable for biomedical or clinical waste. Just to remind you, biomedical waste is nothing but waste that are generated from the hospitals, medical centers and other clinics. And you all know these biomedical waste contains a lot of pathogens and infectious material, and it requires very high temperature and this acts like a disinfectant also, and it kills all the pathogens at this particular temperature, and that is why incineration is more popularly used in the treatment of biomedical waste. Now, in addition to these, incineration process also removes harmful toxins. Now, in recent times if you see, these incinerators are also used for recovering a lot of energy from the heat that is generated during the combustion of waste. Now, you add waste into an incinerator, you supply oxygen, you apply heat of 900 to 1100 degrees Celsius. During the destruction of waste, huge amount of heat is generated. Now, this heat is converted into electrical power through rotation of steam turbines. It is almost similar to your electricity generation. In a normal electricity generation or in a thermal power plant or a nuclear power plant, what happens is, like the heat that is generated during the burning of coal, combustion of coal, that is used to heat the water, and the steam that is generated will rotate the turbine, and this turbine will end up in generation of electricity. The same thing is applied here also. In conventional incinerators, you do not have this energy recovery in terms of electricity, but in modern incinerators or the recent incinerators, they have this additional feature of recovering heat in the form of electricity. Now, this figure shows an incinerator. Now, you can see this incinerator is a double walled, it contains a double walled chamber, and the waste is added, and you have an inlet for the entry of air which causes the combustion, and then heating is done, the waste is burned, and once it is burned, the gaseous products that are produced are just liberated and it is collected, and the flue gas is released outside from the top, and at the bottom the ash is left out, and the ash is collected later and then disposed of safely into a landfill. Now, let us discuss about the advantages of incineration process. Now, as I told you earlier, this requires less space in the landfill, which means this provides a maximum reduction in the volume of waste, about 95%, and reduction of mass by 80 to 85%. Now, as a result, the inert residue that is left out is very less, and when it is disposed of in the landfill, it reduces the space requirement in the landfill. So, incineration reduces almost 95% of waste volume, and the ash that is left out is taken or disposed of into the landfill. Now, since it is a small quantity, just 10% of waste, it reduces the overall space of the landfill. Second advantage is like incineration can be a small modular unit, and it can be installed near the point of waste collection. Because these are very small contact units, just you can fix it anywhere near the source of generation or in the transfer station, or even at the site of disposal you can fix these incinerators. The third advantage is that waste is reduced into a biologically sterile ash product. That means biomedical or clinical waste which contains a lot of pathogens and infectious material in that, incineration is more suitable. This again we discussed earlier. So, it produces a product which is highly sterile. Even when these biomedical wastes are subjected to this incineration process, it kills all the pathogens, results in the generation of ash that is free of all these pathogens. So, it also acts like a sterilizing unit. The fourth advantage is that the incineration process does not produce methane gas unlike your landfill. In your landfill, during the waste degradation process, not only landfill, the other biological conversion route when you talk about, they result in the production of certain gases. Now, the gases can be the carbon monoxide, methane gas, all these have global warming potential. In incineration, again you do not have any production of methane, but carbon dioxide is produced. Incinerators acts like a waste to energy plant. As I told you earlier, now in recent times the modern incinerators are used for recovering energy from the heat that is generated during the combustion of waste. So, it acts like a waste to energy plant where the electricity is produced. So, waste incineration can be a source of low cost energy to produce steam for electrical power generation. Now, the bottom ash that is left out is actually inert, non-injurious, and that can be used for material recovery, or it can be used as a secondary aggregate in the construction process. Again, this is one of the best environmental option for many of the hazardous waste like your inflammables, volatile materials, toxic and infectious waste. Now, these are the advantages of incineration process. Just like any process, if you have certain advantages, obviously it will have demerits also. Now, let us discuss about the disadvantages of the incineration process. Now, the disadvantages as such, if you see, though incinerators does not produce methane gas, it produces other gas which also have or act like an environmental pollutant. One is your carbon dioxide. Now, carbon dioxide, just like methane, again it has global warming potential. Then is your carbon monoxide. I am sure you know carbon monoxide is a very serious gas or dangerous gas which combines with your heme in your blood, and it reduces the oxygen carrying capacity of your blood. So, carbon dioxide, now when is carbon dioxide produced? It is produced during incomplete combustion when your oxygen is not available. Likewise, the oxides of sulfur, oxides of nitrogen, they are also an air pollutant. Now, these gases that are produced in the incinerators makes it more disadvantageous treatment process. In addition to these air pollutants, as I told you earlier, you also have certain dioxins and furans that are produced when you burn the commingled waste. Commingled is nothing but a waste that is added without any segregation. Now, the commingled waste, it will contain everything, it will have plastic, it will have biodegradables, it will have paper, n number of items it will have. Now, when you have plastics in this commingled waste and these plastics are burnt in an incinerator, this results in the production of furans and dioxins, and these pollutants are carcinogenic. This again limits the application of the incineration process. Even the fly ash, the ash that is produced during the incineration process, it is of two types. One is your fly ash and the other one is your bottom ash. Now, the bottom ash will not suspend in the air, it will remain at the bottom. It is easy for you to collect it and then dispose it. But when you dispose it off, if you have one wind, it will carry all the ash. Now, there is another component of ash called as your fly ash. Now, the fly ash, what happens is like it is of lightweight and it gets mixed in the flue gas, and then it just when the flue gas is emitted outside, your fly ash is also emitted outside, and again it acts like a major source of the particulate air pollutant. So, on the whole, if you see, incineration process creates a lot of air pollution problems, but if you have proper particulate and gaseous pollutant control devices, then it becomes a very good option for the treatment of municipal solid waste. Now, in addition to this air pollution problem, it also has other disadvantages like your high investment cost, operation cost and maintenance cost, because you know supplying or creating a heat of 900 to 1100 degrees Celsius requires a large amount of energy. So, it is considered as an energy intensive process due to energy consumption. There is another problem that incinerators generally face, that is a corrosion problem. Now, I told you earlier, in addition to this carbon dioxide, carbon monoxide, you also have a generation of HCl, HF and these acids. Now, these acids generally create or corrode the walls of the incinerators. Now, this is generally, these acids are generally produced during combustion of chlorine containing waste like your paper. Now, this is again considered as a disadvantage of your incineration process. Now, this inner wall corrosion, or sometimes what happens is like the emission pipelines gets abrated due to the deposition of the particulate matter. This makes the pipe very hard and brittle, and it breaks very frequently. So, as a result, you have to keep the maintenance cost of incinerators keeps increasing. Now, another major disadvantage of the incineration process is like the heavy metals that are present in the waste, they are not transformed or converted or broken down into any other material. They remain as such in the ash, which when disposed of or which when you are not disposing it off in a safe manner, it can cause health hazard even in a minor amount. So, disposal of ash is again one major thing which you have to focus on, and you have to do it properly. Now, one more disadvantage of this incineration process is that the heat generation from the waste depends upon the calorific value of the waste. Now, generally what you do is you segregate the waste. Once it comes to a transfer station, you segregate them, like you segregate paper, you segregate plastic, you segregate biodegradables, and whatever is left out, I mean the combustible portion is very, very less. Now, the calorific value is one which is going to generate heat, and with this heat you are going to convert it into electricity. Now, when you recover these materials like paper and plastic, the overall calorific value of the waste will get reduced. Now, once it gets reduced, obviously the heat generation will be less, and when you talk about the energy recovery from these waste, it will be minimized. So, sometimes that becomes a major disadvantage of the incineration process when you are planning to recover some energy from them. Now, generally local communities generally oppose these incineration plants because of certain the air pollution problem or the heat generation in the locality. It influences the local climate in this particular area, and these incineration process requires skilled operators. That again becomes a disadvantage in terms of the operating cost, because you have to pay money to the skilled operators, and skilled operators they require more money. I mean the wages are little higher. Now, let us discuss about the applicability of incineration process, where for which particular waste incineration process can be used. Now, incineration can be applied or used only if certain criteria are there in the waste. First criteria is that you can use incineration process where waste management is practiced for a number of years. Second, you have to have a stable supply of combustible waste. Third, large scale systems generally require a minimum amount of at least 50,000 metric tons of waste generation per year. So, in that condition you install an incinerator that will be helpful to you, and it will recover some energy. Then fourth one is like, as I told you earlier, calorific value of waste is important, because when you recover certain materials, the overall calorific value of waste comes down, and this makes incineration little inefficient. Now, the calorific value of the waste, when you have to set up or you have to put it in an incineration process, the minimum calorific value of the waste should be at least 7 megajoules per kg, and it should not go below 6. The community where the incinerators are installed generally should be willing to pay or bear the cost of tipping fees, tax based subsidies and so on. Now, when all these criteria are fulfilled, then incineration system or incineration plants will be more suitable for that particular area or that particular waste. Dear students, in the first part of this module, we discussed about what is an incineration process. We discussed how incineration process works, how you have to, at what temperature it works, and what amount of oxygen is required, and what are the advantages, disadvantages, and where you can use actually, I mean the applicability of waste, all these things we discussed in detail. Now, in the second part, we will be discussing about the different types of incineration systems that are used. or in short we can see what are the different types of incinerators that are used for burning or combusting the waste. Now, let us discuss about the various incineration systems. Now, for you to design or select a proper incinerator, you should look into certain characteristics. One, they should be designed in such a way to maximize the combustion efficiency of waste, and second, what is the output, heat output that you are going to get. So, it should always focus on minimizing emissions by balancing the oxygen and air, temperature and turbulence. So, these three T's are very important: time, temperature and turbulence are very important when you talk about any incineration technology or process. On the basis of capacity, nature of waste to be combusted, type of system, incinerators are generally classified into the following types: 1. Mass burn incinerators, 2. Modular incinerators, 3. Fluidized bed incinerators, 4. Rotary kiln, 5th starved air or pyrolytic kiln incinerators, and the last one is your refuse derived incinerators. Now, we will discuss few of these incinerators in detail. We will see what are the characteristics. Now, let us discuss about mass burn incinerators. Now, these are incinerators which are used on a large scale burning of waste, and they are called as mass incineration process. Now, it is a simple and a flexible method and generally used for municipal solid waste. 2 or 3 or more incinerator units can be used in mass burn incineration process, and here the burning or combustion of waste is just performed in one single chamber, and per day around 1000 tons of waste can be combusted in the mass burn incineration process. Now, here the pre-processed waste, I mean the segregated or the size reduced or volume reduced waste is brought through trucks to the tipping floor. Now, once they are dropped onto the tipping floor, they are just pushed into a pit through a bulldozer. Now, this once it is pushed into the pit, then they are slowly fed into an incineration chamber through a chute and a grate system. Since mass burn incineration combusts huge amount of waste, they are generally built in a way to recover energy. Now, as I told you, when you compare modern incinerators with the conventional incinerators, modern incinerators generally focus on recovery of energy, unlike your conventional incinerators. Now, modern incinerators consists of a refractory lined combustion system with a steam generator to recover energy, either in the form of heat or electricity. Now, the steam generator will be double walled and it is generally lined with a refractory material, and water will be circulated between the walls, which will be later converted into steam by the heat that is generated during the process of waste burning. Now, if you talk about or if you see the units of a mass burn incinerator, it has 5 main areas, starting from your waste feeding system, furnace, heat recovery unit, emission control unit and energy recovery unit. Now, let us discuss each of this in detail. Now, a waste feeding system consists of again 3 different units. One is your delivery system, a bunker and a feeding system. Now, waste collection vehicle that enters the processing site, I mean the transfer station where the incinerators are fitted or fixed, will be weighed at the entrance both during the arrival as well as departure. This will help them to determine what is the amount of waste that is coming in for the incineration operation. And the waste that is brought to the processing site will be stored in bunkers, and through this bunker they will be fed into the incinerators. A bunker generally can store around 1000 to 3000 tons of waste, and they are divided into different sections to store the waste of different calorific value. Now, long term storage of waste will generally lead to rotting and odor problem, and the hazardous waste and bulky items should be generally separated and then they are stored in the bunkers. Now, a feeder will consist of a steel hopper through which the waste is fed into the incineration system or unit. Now, through a grate by hydraulic ram, the waste is fed. Now, to avoid any air leakage into the furnace, the hoppers are generally half filled with the waste. Now, you also have on top you have hydraulic shutters which are used to seal the hoppers at the furnace entrance to prevent the fire from back burning the waste. To be very specific, what happens is like after you add, when the waste is just entered or when you are feeding the waste into the incinerator, you will have a lot of the fire which is there. What happens is like the waste tends to catch up fire. So, if you have a shutter, you close it so that the bunker does not catch fire, the bunker which is storing the or having the waste will not catch fire. So, that is the reason of having a shutter system here. Now, the next area in a incineration unit is your furnace. The waste is fed in such a way that the incinerator combusts only 50 ton of waste per hour. Now, sometimes you also have multiple furnaces that are used for combusting the waste. Now, this might act as a standby also when you have during the repair or maintenance process. If one incinerator is working, then the other incinerator can act like a standby. Sometimes auxiliary burners are also used to increase the temperature of furnace, especially during the startup process. Within a furnace, the incineration occurs in 3 stages. The first one is drying and devolatilization. During this process, what happens is the moisture that is present in the waste is removed. This is removed due to the preheated air or temperature, initiating temperature, or the heat that is radiated from the incinerator walls. Then what happens is the organic matter which is present in the waste, they will generally undergo thermal decomposition and they result in the formation of or generation of various gases, volatile organic matter like your hydrogen, carbon monoxide, ethane and other high molecular weight hydrocarbons. In addition to that, you also have combustible gases and vapors that are being produced. Now, during devolatilization, what happens is this occurs at a temperature of 200 to 750 degrees Celsius, and this actually begins at the end of drying phase. Now, the release of volatiles generally occurs at a temperature of 425 to 550 degrees Celsius, and generally that depends on the nature and the physical state of waste. The second stage is the combustion of volatiles and the soot that is generated during the drying and the devolatilization phase. Now, the volatiles that are released during the first stage are burnt in the combustion chamber located above the grate. Now, high temperature, complete mixing, long residence time and excess air are generally required for complete combustion of these volatiles, and the gases are subjected to 850 degrees Celsius for 2 seconds to ensure complete combustion of volatiles. Now, the temperature above 1200 degrees Celsius are generally avoided to prevent the formation of slag by fusion of ash residue. The gases must be held in the combustion chamber for a minimum period of 2 to 4 seconds to achieve complete combustion. Now, the third stage is the combustion of solid carbonaceous residue. Now, after the burning of volatile gases, what happens is the residue contains a lot of carbon in the fixed form. Now, the char is burnt in grate for 30 to 60 minutes. Now, the ash, the bottom ash, which is around 30% of the solid waste, is discharged into water trough for cooling and which is later disposed of into a landfill. The fly ash is then collected through cyclones, electrostatic precipitators or bag filters. These are nothing but air pollution control devices which are just fitted onto the incinerators and then they are disposed of. So, these are the 3 different stages, and after 3 different stages what happens to your ash is also discussed here. But actually if you see, though we discuss these 3 stages like drying, devolatilization, then combustion of your volatiles and combustion of the carbon, these stages are not clearly distinguished within the incineration process due to certain factors. Now, these factors include the moisture content, thermal degradation temperature, volatile composition, ignition temperature and the carbon content. Now, this figure shows a mass burn incinerator, I mean the modern incinerator where you have all the 5 different sections we have discussed. If you see here how on the left side you can see a truck which comes and drops the waste onto a tipping floor and then it is falling onto a pit, and from the pit you have a fork unit which is picking up the waste and it will drop into the furnace. Now, through the chute and grate system, it will slide down and then it enters into the incinerator where it is burnt. Now, once it is burnt, the flue gas is just released and it is controlled after subjecting it to the air pollution control devices. Finally, they are discharged into the atmosphere. Now, at the bottom, if you see, the ash that is generated is again slides down, it is collected onto an ash conveyor belt and finally it is carried off or transferred to a truck and then it is taken to a landfill where it will be safely disposed of. On top near the flue gas generation, you can also see the heat that is liberated. It is used for heating the water and converting it to steam. Now, this steam is again collected and it is used to rotate the turbines, and once the turbine is rotated, then it results in the generation of electricity. In a modern incinerator, I told you there are 5 areas like waste feeding system, then you have a furnace, and then we have a heat recovery, emission and energy recovery. So, we discussed about waste feeding system, furnace, and now we will discuss about heat recovery. Now, the heat that is generated during the incineration process escapes as flue gas at a temperature of around 1000 to 1200 degrees Celsius. Now, this flue gas is cooled in boiler when the heat is used to boil the water, and this water, when it is boiled, it gets converted into steam. Now, this steam again has a potential to rotate the turbine, and through the turbine the electricity is generated. Now, meanwhile, what happens is the flue gas are generally corrosive in nature and they contain a very high level of particulate matter. So, as I told you earlier, incineration process has a lot of air pollutants. So, you have to have a control device. So, that is the next or the 4th area where we will discuss about the emission control. Now, the flue gas which contains the particulate matter, acid gases like HCl, HF, sulfur dioxide and heavy metals like mercury, cadmium, lead are generally controlled through cyclone separator, bag filters, electrostatic precipitators for the removal of particulate matter, scrubbing, adsorption and absorption for removing your gaseous pollutants. So, the last main area in your incineration or mass incinerators is your energy recovery. As I told you earlier and as I showed you in the figure also, the steam that is generated by the boilers rotates the turbine due to very high pressure and temperature, and through various stages the velocity of the turbine shaft increases and they result in the generation of electricity. Now, overall around 0.3 to 0.7 megawatt per hour energy is produced from incineration process when you combust 1 ton of municipal solid waste, and they depend on various factors which again we have discussed earlier, like your calorific value of waste, plant size, steam parameters and so on. Now, the second type of incinerator is your modular incinerator. Now, the modular incinerators are very small portable units with a capacity of 5 to 120 tons of solid waste per day. They are more suitable for small communities, commercial and industrial operations. Now, you can also have a very small incinerators with a capacity as low as 15 tons per day to a total capacity of 400 tons per day. You can have even very small modular incinerators, and any number of units can be added onto the original incinerator unit. Now, addition or detachment of a unit will always depend upon the waste generation that is coming in and the service that you require. Now, modular incinerators, as I told you, they are prefabricated. You do not have to construct them, they are prefabricated units and they are just brought and then installed within a short period of time. The cost of construction of these modular units are very less when you compare it with the mass burn incinerators. Now, a modular incinerator, again it contains a refractory lined furnace and a waste heat boiler. Now, 2 combustion chambers are used in modular incinerators. If you remember, in mass incinerators, I told you the combustion occurs in one single chamber, unlike your modular incinerators where you use 2 combustion chambers. Here, the gas that is generated in the first or primary chamber is again fed to a secondary chamber to achieve complete combustion. This again will reduce the emission of the air pollutants. The majority of these modular units, they produce steam as a sole energy product, and generally these modular incinerators are operated in batch as well as in continuous mode. The third type of incinerators is your fluidized bed incinerators. Again, it is a small scale incineration unit with a capacity of 50 to 150 tons of waste per day can be burnt. Again, it consists of a refractory lined vertical chamber. Here it contains, the chamber contains a bed of sand, silica, ceramic and limestone. Now, the air is blown at the bottom of the chamber and this air fluidizes the bed material. Now, the heat supplied to the bed increases the air velocity and it causes the bed to bubble. Now, these beds operate under long residence time. The solid particles are exposed to the heat zone for a long period of time. The turbulence that is generated within the chamber causes the solid material to flow above. I mean it bubbles in such a way that the waste keeps bubbling like this and the waste material just goes up and down the incinerator unit. Like other incineration unit, you also have a cyclone separator which is fixed. This is generally used to collect and recirculate the material back to the bed, because while bubbling some waste tries to escape out, where the cyclone separator can be used to collect and then recycle them back to the bed. Now, the advantages of this, if you see, it has a better combustion with minimized air emissions due to high burnout. To achieve better combustion, the bed materials are generally preheated. You heat them and then you heat them before adding the waste material. Now, when you do certain pre-processing, like when you do shredding, again that increases the efficiency of the system. The dispersion of incoming waste and sufficient residence time are major reasons to achieve to obtain complete combustion in fluidized bed incinerators. There are two types of fluidized bed incinerators, one is bubbling bed and the other one is circulating or turbulent bed. The airflow pattern, bed material and type of waste differentiate the bubbling bed from the circulating bed fluidized incinerator. These fluidized bed incinerators are more compatible with high energy recovery recycling systems. Now, advantages, as I told you, relatively low capital and maintenance cost. Due to simple design, high thermal efficiency of up to 90%, they are more flexible and consistent with energy conversion efficiency. Also, they produce less residual ash and lower emissions, and they are more suitable for handling liquid or solid waste either separately or in combination. They reduce toxic and dangerous substances. If you talk about the disadvantage, this type of incineration process is not so very common and they are not more popularly used. They require pre-treatment, they have stringent requirement for size, calorific value and ash content. They are relatively strict and they demand great size and composition of the waste. The next type of incinerator is your refuse derived fuel, and they are referred to solid waste that is mechanically processed so that it can be used as a fuel. Now, refuse derived fuel, in short called as RDF, are easily stored and can be transported for use anywhere in the world. It involves two steps, namely RDF production and RDF incineration. In RDF production, the waste materials are segregated by using a different air classifier, magnetic separation and so on. Then they will be shredded and then pelletized. Now, once these pellets are formed, then they are combusted. Now, RDF combustion, again it is of two types, one is simplified process and the other one is shred and burn system. In a simplified process, the combustibles are removed and which consists of almost 85% ferrous metals and non-combustibles like dirt, sand, non-ferrous metals, etc. Now, after segregation, they will be shredded into small sizes and then they are fed into the incinerator for combustion. In a shred and burn type, they do not focus on removal of combustible. The waste is just dropped onto the tipping floor, shredded and directly fed into the incineration without any segregation. This type of RDF production is generally very easy and a simplest form because it does not involve any processing. Now, the ash that comes out of this incinerator are then subjected to the magnets which helps in removal of non-ferrous metals. Now, depending upon the combustibles, the ash content also will vary. Higher the combustible, lower will be the ash content. High ash content leads to again a low quality fuel. When pre-processing of waste is carried out before incineration, it adds to the operating and maintenance cost. Then it also reduces the reliability of the RDF production. Generally, if you see, these RDF technology is more costly than other incineration options. Now, let us discuss about the energy content of waste. Now, how do you calculate the energy content of waste before subjecting it to an incineration process? Now, energy content of waste is calculated using the ultimate analysis of waste. Again, if you go back and remember, we discussed about the ultimate analysis in the characterization of waste. Now, they are generally expressed. Ultimate analysis means analysis of your carbon, hydrogen, oxygen, sulfur and so on. Now, the energy content is generally expressed as kilojoules per kg or BTU per LB. BTU is nothing but British thermal unit. Now, Dulong's formula is used to calculate the energy value of waste, and it is given by 145.4 carbon plus 620 open bracket H minus 1 by 8 of O close bracket plus 41 S, where C denotes your carbon, H denotes your hydrogen, O denotes your oxygen and S denotes your sulfur. These are all calculated based on the percent by dry weight basis. The value that you get in BTU per LB can be converted into kilojoules per kg by using this formula, where the value that you get, like BTU per LB, if you multiply with 2.326, then it will be converted into kilojoules per kg. Now, in this table, if you see, this table provides the ultimate analysis of the different types of waste that is being generated. If you see, food waste has 48 carbon, 6.4% hydrogen, oxygen 3.7, nitrogen 2.6, sulfur 0.4, ash 5. So, if you take food waste as an example, now what would be the energy efficiency of food waste? That is calculated below, and you can see that that is provided in the table below the table, where you see you pick up you apply this carbon, hydrogen, oxygen values in the formula, I mean the Dulong's formula, which was 145.4 into 48, that is carbon, plus 620 into 6.4 is hydrogen and 37.6 is your oxygen, plus 41 into 0.4 is your sulfur. So, total energy efficiency or energy content that is present in the food waste is around 8049, I mean 8049.6 BTU per LB. Likewise, you can calculate for other different types of waste, where for paper again we have provided the ultimate analysis, cardboard you have different carbon, hydrogen, oxygen content, and with this for each type of waste you can calculate the energy content or energy efficiency of the waste. To summarize, at the end of this module, we have familiarized the concept of incineration. We have discussed what is incineration and at what temperature the waste is burnt, that is 900 to 1100 degrees Celsius, and what is the requirement of oxygen, how important is oxygen. Then we familiarized the incinerator unit, how important is an incineration unit, what are the parts of an incineration unit. Then we discussed about the various advantages and disadvantages of the incineration process. Then we discussed about the applicability of incineration, where the waste or to which waste the incineration process should be subjected. Then also what are the criteria that you will look into for deciding what type of incinerators or where the incineration should be subjected. Then last we discussed about the different incineration technologies, like your mass burn incinerators, modular incinerators, fluidized bed incinerators, then your RDF incinerators. For each we have discussed about the merits and demerits also. Lastly, we discussed about the energy efficiency of waste, how the energy efficiency of waste is calculated based on the Dulong's formula. The energy efficiency is very important, because only when you know the energy efficiency you can decide whether the waste can be subjected to the incineration process or not. I hope this module would be of help to you. Thank you.